Okay, welcome everyone. Today we're discussing the 2019 AMC 8. Feel free to ask any questions as we go, but otherwise I'll just work through it in order. Okay, so we start with question one. Ike and Mike go into a sandwich shop with a total of $30. Sandwiches cost $4.50 each, and soft drinks cost $1 each. They plan to buy as many sandwiches as they can and use the remainder for soft drinks. So counting both soft drinks and sandwiches, we want to know how many items they'll buy. So we're told that they'll first go for $4.50 sandwiches. So we just um, take $30 and divide by 450. And this divides no times into 3, or sorry, yeah, 450 doesn't go into 3, but it does go into 30. It goes in 6 times. 6 times 450 is 27. So if we subtract that, we're left with $3 remainder. So we know they can buy 6 sandwiches, and with $3 they can buy 3 soft drinks. So that's a total of 9 items. Okay. And if you ever have any questions, just let me know. Either raise your hand or call out, send me a chat, anything. Okay. So you have 3 identical rectangles which are put together to form this rectangle, ABCD. We're told that the shortest side of the rectangles is 5 feet. I'll just take this one. And we want to know what the area of ABCD is. So we can see that these 2 short sides, each of these is 5. They perfectly fit along the long side. The long side has to be 10. So we can label all the long sides as 10 because we know the rectangles are all identical. And then it's just 10 times 15, length times width. That's 150. Okay. Question 3. We want to order these 3 fractions from least to greatest. So it's kind of annoying because of the denominators. We could go for common denominators, but that might be tedious. One thing we can do is subtract 1 from every number because that won't change the ordering. So 11 or 15 over 11 would become 4 over 11. 19 over 15 becomes 4 over 15. And finally we have 4 over 13. So we've subtracted 1 from everything and we're left with a 4 on top for every number. So that's good because now we can just compare the denominators. The one with the largest denominator is going to be the smallest fraction because we split the whole into the most number of pieces. And since we're taking the same number of pieces for each one, the one with the smallest individual piece is going to be the smallest one. So that means that 4/15 is the smallest, which corresponds with 19 over 15. And then similarly, 4 over 13 is the next smallest. And finally, 4 over 11 is the largest. So we pick D as our answer. And let me just see it. Oh, one of the answers got cut off, but D was the answer. Okay. Let's move on to problem 4. We'll go a little bit quicker today because last time we went over. We have this quadrilateral, which is actually a rhombus, we're told, with perimeter 52 meters. We're also told that the length of the diagonal is 24, and we want the area. Okay, so we have this diagonal, and we know the perimeter equals 52. Because we have a rhombus, we know that all 4 sides must be equal. So if we do 52 divided by 4, that's 13. So we know all 4 sides have to be 13. Okay, it's a good start. Now we'll want to draw this other diagonal. and we'll see why. So we're told that AC was 24, but because this is a rhombus, each of these four individual triangles are identical. They're rotated or reflected, but they have the same side lengths as well as angles. So these are perpendicular because we have four equal angles that add up to 360. So each of them is 90. We know that each of these sides is 12 because BD has split AC in half because these two triangles must be equal and therefore they must both be 12. And finally, we'll use the Pythagorean theorem on this triangle. I'll call this intersection point X. So we'll use the Pythagorean theorem on AXD. We'll get 12 squared plus BX squared is equal to 13 squared. And that's by the Pythagorean theorem. So A squared plus B squared is C squared in a right triangle. 12 squared is 144. 13 squared is 169. So we can deduce that this must be 25. And if bx squared is 25, then bx itself must be 5. But in order to find the area, we need to use this 5 somehow. So we'll try to find the area of one of these triangles and then multiply by 4. So times 4 down here just so we don't forget. And we'll try to find the area here. Because this is a right triangle, we can use, well, any triangle we can use base times height divided by 2. But because this is a right triangle, we can just use these two sides because they're already base and height. So we do 5 times 12 divided by 2 is 30. And so 30 times 4 is 120. Okay. Okay. Scroll down. Oh, great. Another answer got cut off. It's unfortunate. Nice. Switch over. Okay. Okay. We have a tortoise who challenges a hare to a race. The hare agrees and runs ahead and leaves the tortoise behind. Confident that he will win, he stops to take a nap. So then the tortoise walks at a slow, steady pace for the entire race. The hare awakens and races to the finish line, only to find the tortoise already there. So we want to know which one of these graphs accurately matches the description. So this graph got cut off, but it's not the right answer. I might switch to the other PDF after this, just because these answers are getting cut off. Okay, let's look at graph A first. So we know that the one that's not changing at all is probably going to be the tortoise, right? You see our axes are distance and time. So this is probably the finish line then. Okay, so by this graph, the tortoise would arrive after the hare. So we can immediately rule this one out because we know that the tortoise is supposed to win the race. Option B, we see that the tortoise does arrive before the hare in terms of time. So this definitely does seem possible. Let's see if everything else matches. The hare gets an early lead. It makes sense. He's getting further, but then he stops to take a nap. That seems reasonable. He's not moving at all. And then when he catches up, it's already too late. So this definitely seems good. We'll check the other ones just to be sure. The tortoise should not be changing his speed. So we can rule this one out because it has a little curve here. So we'll rule that out. And for this one, the tortoise does arrive first. But if we think about the hare as they nap, they should not be moving forward as they nap. So we can also eliminate E. Okay, so B is the correct answer. Okay, we have 81 grid points in this square. I'll get rid of those. And we're told that P is the center. Okay, we have Q randomly chosen from among the other 80 points. We want the probability that PQ is a line of symmetry for the square. So we know that a square is going to have 4 lines of symmetry. One this way, one this way, as well as 2 diagonals. So all we have to do is count how many points lie on these lines of symmetry. And we can see that they're actually like 4 in every direction. And multiplying that by 8 directions, 4 times 8 is 32 points that work. There are 80 possible points, 81 minus P because we can't pick P again. So we just have 32 divided by 80, which is 4/10, or 2/5. Okay. Any questions so far? Cool, cool. Let's move on. Okay, Shauna takes 5 tests, each worth up to 100 points. Her scores are given 76, 94, and 87. In order to average 81 over 5 tests, we want to know the lowest score she can earn on one of the other 2 tests. So if she's going to average 81 over 5 tests, we know that her total must be 5 times 81. It's kind of hard to see. Because that way we can take the total, divide by the number of tests, and get 81 back. Now her other 3 tests add up to 257. So if we do subtraction, we'll get that she has to get 148 points on her next 2 tests. For the lowest score she can get on one test, if she's getting the lowest possible score on one test, that would also be the same as getting the highest possible score on the other test. So the highest possible score is 100, and if she gets 100 on one of the tests, the other test would have to be 48. That's her answer. Okay. Problem 8. Gilda has a bag of marbles. She gives 20% of them to her friend, Pedro, then 10% of what's left to Ebony, and finally 25% of what's left to Jimmy. We want to know what percentage of her original bag of marbles she keeps for herself. So the best way to do this, whenever we see these kind of percentage problems, always good to assume that she has 100 to start, because it makes a very easy calculation at the end. Whatever's left divided by 100, so that just means whatever's left is the answer. So after giving 20% of them away, she's left with 80. Giving 10% away, 10% of 80 is just 80 divided by 10, which is 8. So subtracting 8 leaves her with 72. After giving away 25%, so we need to know 25% of 72, that's just a quarter of 72, which is also 18. So we subtract 18 and we get 54. So she has 54 for herself. And that, because we ended with 54 marbles, we can just say, what percentage is 54 of 100? Well, it's just 54, because we start with 100 to make our life easy. Okay, so we have Alex and Felicia. Alex buys cans of cat food. Yeah, buys cat food, 6 centimeters in diameter and 12 centimeters high. Try a different color. So she has like really tall cans, but they're kind of narrow. Okay, and we also have Felicia, who buys much wider cans, but not quite as tall. And we want to know what the ratio of the volume is. So to find the ratio to the volume, we're going to have to find first the ratio or the area of the base and multiply by the height. So it's kind of like a bunch of circles stacked on top of each other, however many times it is high. So with a diameter of 6, we know the radius is 3. And we know that the area of a circle is pi times the radius squared. So that tells us that our base is 9 pi. And because the height is 12, we just multiply those together for a total of 108 pi. On the other can, we have a diameter of 12, which makes for a radius of 6. Applying the same circle formula, we get 36 pi. And now we're only multiplying by 6 for the height. Okay, 36 times 6 is 216 pi. So if we compare 108 to 216, 108 is exactly half. So our answer is 1 to 2. Okay, cool. Let's move on. I think we're, on a good piece, pretty much. Okay. We have a diagram of the number of students at a soccer practice each weekday. We calculate the mean and median, and then we realize that there are actually 21 participants on Wednesday. So we want to find the change after this correction. So we can see that Wednesday previously had 16, and now it's jumping to 21. Okay. So let's first think about what the change to the mean is. The total is being increased by 5, but to calculate the median or to calculate the mean, we would have to divide by the number of days, which is 5. So this is like the change that we make is just plus 5 divided by 5, which is just 1. So that means that the mean is going to increase by 1. So we can rule out D and E. Next for the median. So to find the median, we're going to have to arrange everything in order and find the middle element. So before we had a 16, 2 16s actually, a 20, a 22, and a 26. So we had 20 as our median before the correction. After the correction, we have 16. The other 16 is now 21. So we still have the 20, 21, and we still have the same final 2 elements. So our new middle is 21. So that means that the median increases by 1, which is B. Cool. From 10. Okay. Problem 11. We've got 93 students in an 8th grade class. Each student takes a math class or a foreign language class. We know that there are 70 8th graders taking a math class, as well as 54 who are taking the foreign language class. We want to know how many only take a math class and not a foreign language class. So this sounds like the perfect time to use a Venn diagram, I would say. We'll use one of these. Let's say the left one is math, and we'll say the right one is language. Okay. We have 93 total students, so we know that let's call this M, call this L, and we'll call this B for like both. So we know that M plus B plus L is 93. We also know that there are 70 8th graders taking only math. M plus B is 70. And we also know that there are 54 taking a foreign language class, which is B plus L. And we want to find how many 8th graders are taking a math class, but not foreign language class. That's M, right? If we look at our equations, we can get M by taking our first equation and subtracting the third. Because when we do, the b and the l will cancel out, and we'll be left with just the m. So we have m plus b plus l minus b minus l equals 93 minus 54, which is 39. Here's our answer. Okay, problem 12. We've got a cube painted with 6 different colors, red, white, green, brown, aqua, and purple. We're given 3 views and we want to know the color, the face opposite aqua. Let's take a look. First thing we should notice probably is that we can see a red and a green on Q1 and Q3. We can also see a third face in each, which is this P and this B. Notice that these two, none of them are opposite the red or the green. And that means that they have to be opposite each other. If we imagine drawing the inside of this cube, the only place the P can go is on the bottom because it has to be touching the red and the green. The B is on top, so the P is on the bottom. So that means that B and P are opposite each other, so we can eliminate those answers because they're not going to be opposite the aqua. Now let's look at this center cube. We see this R here. Okay, well, we know that the B has to be touching the R and the G. So that tells us that the G has to be on this face right here. So this face back here has to be the G. We need a different color, make that more clear. This face back here. Okay. Because this is the only way for the R and the G to touch, as well as have both of them touch the B. So what that tells us is that G and W are opposite each other. So we can eliminate 2 more answers and get our final answer of red by the process of elimination. Okay. Any questions so far? Good. Okay. 13. Palindrome is a number that has the same value left to right or right to left. So they give an example, 12,321. We want the smallest 3-digit integer, or sorry, no, we don't want that. We have n, which is the smallest 3-digit integer, which is not a palindrome, but the sum of 3 distinct 2-digit palindromes. We want the sum of the digits of n. So if we look at 2-digit palindromes, they're really just multiples of 11, because that's the only way for them to be the same forward and backwards. And the smallest 3-digit integer, which is not a palindrome, but the sum of 3 of these is going to be a multiple of 11. So we'll go with the smallest 3-digit number, that's a multiple of 11. And now we just have to confirm that it's the sum of 3 distinct 2-digit palindromes, and we can be done. Like we can do that pretty easily. One possibility would be 55, 44, and 11. I guess 1 time. So we want the sum of the digits, so that's 1 plus 1 plus 0, which gives us 2. Okay. Problem 14. Isabel has 6 coupons for free ice cream. She uses them every 10 days. She knows that Pete's is closed on Sundays, but as she circles the 6 dates, she realized none of them are a Sunday. So we want to know when she redeems her first coupon. So let's just draw sort of a cycle to see how this really turns out. We can start with any day, doesn't really matter. I'll start with Monday. If she uses her first one on Monday, then 10 days later, that's a week and 3 days later. So it's going to be the same day of the week as just 3 days after. So we can count up Tuesday, Wednesday, Thursday, and then Friday, Saturday, Sunday. Okay. So we've hit our roadblock sort of because we know we don't have a Sunday. But if we continue, we have Wednesday, Saturday, Tuesday, Friday, and then finally we are back to Monday. So if we think about which one of these days we have to start on so we don't have a Sunday, it has to be Wednesday. That way we can go 1, 2, 3, 4, 5, and 6. So our answer is Wednesday. Cool. Let's keep going. We have a beach where 50 people are wearing sunglasses and 35 are wearing caps. Some of them are wearing both as well. We're told that selecting one of the people wearing a cap at random, the probability that they're also wearing sunglasses is 2/5. So we want to know if we pick someone wearing sunglasses, what's the probability that they're also wearing a cap? So this is a bit similar to the last problem that we did with the Venn diagram. But we won't use a Venn diagram. I don't think we need to. And just have sunglasses, caps, and both. But this won't be just. This will be any. So we'll count someone wearing sunglasses even if they're also wearing a cap. So we have 50 people wearing sunglasses, 35 who are wearing caps. We're told that 2/5 of the people wearing caps are also wearing sunglasses. So 2/5 of 35 is 14. So now if we pick someone wearing sunglasses at random, what's the probability they're also wearing a cap? Well, we know that 14 of them are also wearing a cap, and there are 50 total. So our probability is just 14 over 50, or 7 over 25. Okay. So I'll continue. We have Chung who drives 15 miles at an average speed of 30 miles per hour. And we want to know how many additional miles he'll have to drive at 55 miles per hour to average 50 miles overall. Okay, so we know that 50 miles per hour must be equal to the distance divided by the time. Now we already know that he drove 15 miles for distance. And at 30 miles per hour, he would drive 30 miles in 1 hour, right? So to drive 15 miles, it would just take him half an hour. So we'll say half an hour. It's very important that we write 0.5 instead of 30. And we do that because we measure the bottom in hours. The reason for that is because our unit was miles per hour. So our bottom our denominator has to be in hours. Okay. Now we have to add more to each. The top will be 55x, while the bottom is x. So however many hours he drives extra, he'll drive 55 times that many miles. 1 hour, 55 miles. 2 hours, 2 times 55 miles. And this has to be equal to 50. So let's multiply both sides by 0.5 plus x. So that gets rid of our denominator. And we also have 50 times 0.5, which is 25, plus 50 times x, which is 50x. Subtracting 50x from both sides. And then subtracting 15, we have 5x equals 10. That means x is 2. Okay, well, 2 is not an answer. So we reread the problem. We need to know how many extra miles. So we just multiply by 55 because 2 hours at 55 miles per hour, that's 110 miles. Okay, we want the value of this product. At first, seems pretty tough. We definitely want to look for some ways to simplify this. So we want to look for numbers that are the same in the numerator and denominator. And we see this 3 that we can cancel, as well as this 2 that we can cancel. And in fact, if we keep looking, we can always make these cross shapes that can cancel each other out, even at the end. These 98s will cancel, and the 99s will cancel. So we're left with just the front 1/2. This is all equal to 1 because it all cancels out. And multiply by 100 over 99, which leaves us with just 50 over 99, 1/2 of this last term. Okay. Problem 18. We have the faces of 2 fair dice, which are numbered 1, 2, 3, 5, 7, 8. When the 2 dice are tossed, we want the probability that their sum is even. So we'll need to get an even number, we'll either need 2 even numbers or 2 odd numbers. So we can see that there are 4 odd numbers, 1, 3, 5, 7, and 2 evens, 2 and 8. That gives us a 2/3 chance of rolling an odd number, and to roll a second odd number, we multiply by 2/3 again. That's 4/9. For our second case, if we roll 2 evens, that'll be 1/3 chance twice. So 1/9. So we've got these 2 separate cases. They don't overlap at all. We're never going to be able to roll 2 odds and 2 evens. So we can just add these up and get 5/9. Yeah, so we might have to watch out for adding if there were a way to get both of these simultaneously, but there isn't, so we're good to just add. Okay. We've got a tournament in which 6 teams play each other twice. A team gets 3 points for a win, 1 point for a draw, and 0 points for losing. We're told that after all the games have been played, the top 3 teams get the same number of total points. We want to know what's the greatest possible number of total points. Okay. So we have A, B, C. Let's say that A, B, and C are the top teams. And we have these other teams which did not do as good. Well, to get the greatest total points, we'll have our top teams win their matches against the lower teams. So they play every other team twice. So A should beat D, E, and F every game. That's 6 wins multiplied by 3 points. And that's going to be 18. Well, assume that B and C also dominate D, E, and F, getting 18 points each. So now we just have to think about what happens when A, B, and C face each other. We don't have to worry about D, E, and F facing each other because they don't affect our top teams. For this, we kind of have to see if ties are better or wins and losses are better. If we have 2 teams tie, it'll generate 1 point for each team for a total of 2. If we have 1 team win, that generates 3 points. So that's going to be slightly better overall. So we can have each pair of teams win once and lose once against each other. And that would generate 3 points for each team. You can see that's better than tying twice, which would only be 2 points for each team. So A and B each get 3. B and C each get 3 from playing each other. And then when A and C play, they each get 3. That's another 6 points in addition to what they already had, which was 18. So we have 18 plus 6, which is 24. Okay. Problem 20. We have x squared minus 5, all of that squared, being equal to 16. We want to know how many real numbers satisfy this. So we'll first start by looking at everything that's inside the parentheses. What does that have to be equal to? Based on the square, it either has to be 4 or negative 4. So we'll case on that. Let's break it down. Either this is 4 or it's equal to negative 4. The first case leads us to x squared equals 1, while our second case leads to x squared equals 9. Each of these will have two solutions, which would be 1 for this and negative 1, as well as 3 and negative 3. That's a total 4 different real numbers that satisfy the equation. Okay. Any questions? Cool. We want to know the area formed by the lines y equals 5, y equals 1 plus x, and y equals 1 minus x. So let's get some coordinate grids. And I'll actually do this line. Okay, so we have our first line, y equals 5. We also have y equals y equals 1 plus x, as well as 1 equals y 1 minus x. Okay. Let's look at these lines. This is y equals 5, a horizontal line. This is y equals x, or 1 plus x. So when x is 0, y is 1. That works. We have this intersection point because when x is 0, y is 1 for both of these lines. So we know this intersection point here is 0, 1. We want to know what the other intersection points are though. So we'll set these equations equal in pairs. If y equals 5 and y also equals 1 plus x, then this is basically just 5 equals 1 plus x. So x must be 4. And then y would be 5. So this is 4, 5. And applying the same logic to the other equation, y equals 5 and y equals 1 minus x, x would be equal to negative 4. So now to find the area of this triangle, we'll use base times height. This is probably our most convenient height. And we know the base is 8 because the distance between negative 4 and 4 is 8. We know our base is 8. We just need to know our height. We know this is going to be at y level 5. And we know this is at y level 1. So the difference between those two is 4. We don't really care about the x coordinate. I mean, it's obviously going to be 0. But the y difference is what really matters here. So we can use base times height divided by 2, 8 times 4 divided by 2, which is 16. Okay. Let's keep going. We've got a store which increased the original price of a shirt by a certain percent and then decreased the new price by the same amount. We're told that the resulting price was 84% of the original. So we want to know by what percent the price increased and decreased. So we have the original price, let's call it P. The first change was 1 plus x. So when you multiply by 1 plus x, multiplying by 1 is the original, and then p times x would be whatever the change was. We also multiply by 1 minus the same amount, and we got this was equal to p times 84%. So we see P is on both sides, so we can just cancel those. And that means that 1 plus x times 1 minus x is 84%. So let's do some distributive property. We have 1 times 1 minus x plus x times 1 minus x. So 1 times 1 minus x plus x times 1 minus x. We see that we have minus x and plus x, so we'll get rid of those. And we're left with just 1 minus x squared. We're using the minus right here. So we have 1 minus x squared equals 84%. And 84% is the same as 0.84. So we'll use that instead. Subtracting 0.84 from both sides, we're left with 0.16. And moving this, or adding x squared to both sides, we get it on the right side, and it's removed from the left side. So let's convert this into a fraction now. Because that makes it easier to square root when we can have a concrete number to square root by, especially because 100 is a square number. So taking the square root of both sides, 16 becomes 4, 100 becomes 10, so we have 4/10, or 2/5. Yep, so that makes E the correct answer, because we can convert 2/5 back to 40% if we wanted to. Okay. Any questions about that? Cool. We have after Euclid High School's last basketball game, 1/4 of their points were scored by Alexa, and 2/7 were by Brittany. We have Chelsea, who scored 15, and we have 7 people who scored no more than 2 points each. Less than or equal to 2 points. I'll say each. Okay. We want to know the total number of points scored by the other 17 members. So let's first calculate how much of the points were scored by Alexa and Brittany by adding these two fractions. If we do that, we'll come out with common denominator of 28. So 7/28 plus 8/28, which is 15/28. That means that the other 13/28 is equal to the 15 points plus however many points the 7 people are able to score, which we don't know. If the team had scored 28 points total, then there would be 13 points to be on this right side, but that doesn't make sense because we already have 15. So let's bump it up to 26 of 56 points. So this is an equivalent fraction. We've just multiplied the top and bottom by 2. But now we can have 15 points from Chelsea, and the other 11 of 26 points can come from the other 7 people. One thing to note, if you had gone further up, for example, multiplying top and bottom by 3 for 39/84, you'd be asking 7 people to score 24 points. And because none of them can score more than 2, this won't be possible. They'll at most only be able to score 14. So that's why we only have one answer. Okay. So we've got a geometry problem. We have a triangle ABC. D divides AC such that AD over DC is 1 to 2. Mark that. E is our midpoint. BD actually. Okay. And we are given that the area of ABC is 360. So we want the area of EBF, a little small triangle in the corner. Let's draw an extra line here. That'll be helpful. So one thing to note first is that ADB, this triangle, has an area of 120. The reason for this, AD and DC are split 1 to 2, and the triangles ADB and BDC are going to share the same altitude. So when we do base times height for their areas, ADB is going to have 1 times the height divided by 2, while BDC has 2 times the height divided by 2. That means that BDC is double of ADB. And since they add up to 360, we can calculate that ADB is 120, while BDC is 240. I'm going to get rid of this altitude now. Cool. Now looking at ABE and AED, once again, we have the same idea. Using this altitude, ADE and AEB have the same altitude, and they also have the same base. So they have the same area calculation. So we just have the same base times the same height, which gets us the same area. So we're going to be evenly splitting 120, which would be 60 and 60. Using the same logic on the other side, DEC must be 120, and BEC must also be 120. Okay. Now let's look at this triangle that we've been trying to look for. We consider ABF and AFC, whatever the ratio of the sides are in, it's going to determine the ratio of the areas, because we can use the same logic we've been doing using the entire problem. This altitude, base times height divided by 2, is the same for the other triangle. So the area of the triangles is just the ratio of the sides. And now let's look at this triangle versus this triangle. Once again, their areas are going to be in the ratio of our sides. It's going to be BF times this height from E compared to FC times this height from E. So these two triangles, BEF and EFC, their areas are also in proportion with the sides. So going all the way back, we've shown that ABF compared to AFC is equal to the ratio of EBF and EFC, which is also equal to BF compared to FC, the sides. Okay, so if we subtract, we're subtracting things that are in proportion with each other, so we're not going to affect the proportion. This is similar to taking something like the ratio 6 to 9 and subtracting numbers that are in proportion. So if we subtract 2 and subtract 3, we get 4 to 6, which remains proportional with everything else. So ABF minus EBF is just 60. Look here, ABF and EBF, we just have this 60. And if we look at AFC minus EFC, AFC minus EFC, we just have 180. So we know our proportion is 60 to 180. It's also 1 to 3. And that must be the proportion BF to FC. So now we just have to look at how much area we have left. 60 plus 60 plus 120 is 240. So we have 120 left to be distributed in the ratio 1 to 3. So the only way to do that is 30 to 90. And that gives us the answer 30. Okay, bit of a longer problem there. We repeatedly applied the fact that when you have triangles that share an altitude, the ratio of their areas is just the ratio of their bases. That was the fact that we used like 3 or 4 times, and eventually we were able to get an answer of 30. Okay, final problem. We're told that Alice has 24 apples. We want to know how many ways she can share them with Becky and Chris so that each of the people has at least 2 apples. So they've conveniently named them so that we can use A, B, and C. That's good. And let's make a table. Tables are a good way to stay organized. So we can list a bunch of cases. If, let's say Alice takes the minimum 2 apples, then how many ways are there for Becky and Chris to take their apples? So Becky could take 2 apples, leaving Chris with 20. Or on the other hand, Becky could take 20, leaving Chris with just 2. And Becky can also take anything in the middle, which will leave Chris with something in the middle. So how many possibilities is that? From 2 to 20, there are 19 numbers. So overall, this case gives us 19 possibilities. Our second case is if Alice has 3 apples. In this case, Becky would be able to still have 2 apples, but only be able to go up to 19 because Alice has 1 more. And what this does is it leaves 1 less choice. And if we continue this pattern, we would eventually get to the point where Alice takes 20 apples. And then Becky and Chris would be forced to take 2 apples each, and that would mean just 1 possibility. So to find our answer, we just have to add up all the numbers from 1 through 19, because each intermediate level is 1 more or 1 less. So 19 will leave Becky and Chris 5 apples, for example, and then Becky could take 2 or 3, and then Chris would also take 2 or 3. And obviously they would flip, so these 2 go together, these 2. This would have 2 possibilities, right? So we gotta add up all these numbers. Blue doesn't show up. Let's use red. So we'll use a well-known technique where we just pair up the ends. And each of these pairs is equal to 20. And because there are 19 numbers, there will be 9.5 pairs, basically. Another way you could think about it is the average number is 10. So these 2 numbers have a total of 20, so their average is 10. That means that the average number is 10, and because there are 19 numbers, we get 190. If you wanted to think about it in pairs, you could do 20 per pair, and we have 9.5 pairs. You get the same answer. The reason we have a half pair is because middle number 10 doesn't pair with itself. So we're just left with half a pair. You can also do the average number to avoid this problem. But either way, we get C190 as our final answer. Okay, so 7:55, it's pretty good timing. I'll end the recording here. Thank you all for coming.